Hey everybody, how are you doing? My name is Brandon Bro and welcome to part 3 of building a real life Claptrap. And today we're going to be building the frame. So get excited because we're about to begin. Alright, so when building Claptrap, I want to make sure that we are going to be able to achieve a couple of things. One is that he was going to be long lasting and most reflective of the character in game. Now, while I could make him easily out of wood, I decided that metal was probably going to be our best bet. Secondly, modularity. I wanted to make sure that if something ever broke or malfunctioned, we'd be able to replace it really easily. So those were the two things I wanted to hit on, but let's go ahead and get started on designing the frame. Hopping over into Fusion 360, I've already scaled it, and if you happen to miss that in the last episode, I'll leave a link up above and down below for you to check it out. But when I first started out, I thought I knew exactly how I was going to do this, and I created a shape, shelled it out, and then created some brackets. But what I found was that those were going to be really awkward to cut. They have those compound angles. So I took another approach. Starting all over again, what I came up with was this, where I actually have the frame centered, having supports going straight up from the bottom. And moving forward a little bit, you can see that I added some parts up top that were going to help with the arm supports. And this took me a little while to figure out how I was going to do this because ultimately I'd like to make the exterior out of sheet metal. And here you can see the wheel supports, which I think I might have an issue with just due to torsion on the wheel. I think that with the PVC that I intend on using for this and it being round, when I go to make a turn, it's going to actually torque itself out of there. But moving forward a little bit, I made what was like a bike dropout, which is really what I was modeling it after. And then here are the arm supports framed up, and I made some 3D printable brackets because the angles in Claptrap are not simple. Just like the ones for the exterior, the ones on the interior are pretty complex as well. So to simplify that, I made these angle brackets. And then moving on to the front and back, we have a complete frame. And I added these little notches up top just so that I could get an orientation of how these were going on. Here I am just getting the lengths of each bar so that I know exactly how long to cut the aluminum to. Now that we have an idea of what our frame is going to be like, I wanted to search up some aluminum, and I took one out of the 3D printer's handbook here and went with some extruded aluminum, and I got them in 1 meter lengths. This was going to give me plenty of material to play around with, but then I was going to need some fasteners along to go with it. Looks like these will do all right. These will give me really good support on all of the corners, which is really primarily what this frame is going to be made up of. Now that we have our material selected and it's finally come in, the next order of business is to actually cut it. But before we do that, gotta be safe. Alright, so the frame is all built up. The last thing to do is to put the wheel on. And it definitely gave me some troubles. which I kind of figured was going to happen because the wheel is so massive and it is going to encounter so many different stresses. I wasn't quite sure how PVC or 3D printed parts were going to hold up, and ultimately I would have liked to have built this out of aluminum as well, but I didn't have the machinery to press cut the dropouts the way that I wanted to. So I pressed on and met lots of failure. After printing another set, I came up with some more amounts and I was able to get them on. Everything was looking good until I started mounting it. I spaced the tubes apart far enough to get the dropouts in, accidentally pinched my Hall effect sensor in there, and unfortunately when I started tilting the entire frame with the wheel back, I should have noticed that it was starting to come apart, and as soon as I started to keep going down, fail number 2. It had completely torn apart this print. This is where I learned about layer adhesion and how you should really be 3D printing your parts. It left those nubs in the tubes, and I pretty much had to start completely over. So I went back and started really investigating what was going wrong, and the layer adhesion was really what was messing me up here. The last part I printed was printed mainly in Z, and what that meant was if this part encountered any kind of perpendicular movement, it was going to tear it apart. What I did was laid it down flat. The only bad thing to this was if I go over to the layers, you can see that there are steps. And if this was going to be a finished product, I might have been a little bit more upset about this, but the fact that the nut was actually going to be able to hold on to the dropout a little bit better, I decided to press on. So after a lot of 3D printing, a lot of mistakes made, I was finally able to get a dropout that was going to work, which made our Claptrap frame complete. And here it is. Alright, and that's going to do it for this video today, guys. Thank you for joining me, and as you can see, the frame is absolutely huge. I took some measurements after it was all stood up, and it measures out to about 39.5 inches, which is pretty darn tall for a robot. So if you like what you see, and you want to see more, go ahead and give a like, give a comment, and go ahead and hit that subscribe button down at the bottom. Until next time, take care.